Hi students, in this class we will study how we can convert the three-phase unbalanced currents into its equivalent symmetrical components. These are the three unbalanced currents. We have to convert this into the symmetrical components. The zero sequence current, positive sequence current and negative sequence current. This is the formula we are using to convert this into symmetrical components. It is 1/3 into the transformation matrix, the phase currents IA, IB and IC. The transformation matrix is 1, 1, 1, 1 alpha, alpha square, 1 alpha square, alpha. Here alpha equals 1 angle 120 degrees, alpha square equals 1 angle 240 degrees. Let's first find out the zero sequence current IA is 0. This is equal to 1/3 into IA plus IB plus IC. IA plus IB plus IC. This is equal to 1/3 into IA equals 100 angle 0 plus IB equals 110 angle minus 100 plus IC equals 115 angle 110. Let's convert these polar terms into its equivalent rectangular terms, as we have to add the three quantities. It is 100 plus J0 plus this is equivalent to minus 19.1 minus J108.33 plus the last term is equal to minus 39.33 plus J108.06. And this is equal to 13.86 minus J0.09. The final answer should be written in the polar form. This is equal to 13.86 angle minus 0.37. Because when you write the final current term, it should have the magnitude and angle. This is the zero sequence current in the A phase. These are the zero sequence currents, IA0, IB0 and IC0. All are equal. The three zero sequence currents are equal. This is equal to 13.86 angle minus 0.37 degrees. Now let's find out the positive sequence currents. The positive sequence current IA1 equals 1/3 into IA plus alpha IB plus alpha square into IC. IA plus alpha IB plus alpha square into IC. So this is equal to 1/3 into IA equals 100 angle 0 plus alpha equals 1 angle 120 degrees into IB equals 110 angle minus 100 plus alpha square equals 1 angle 240 degrees into IC equals 115 angle 110. So this is equal to 1/3 into 100 angle 0 plus 110 angle 120 minus 100. This is 20 degrees. Plus 115. This is 240 plus 110. So it is 350. Now let's convert these polar terms into rectangular terms, as we have to add the three quantities. This is 100 plus J0. This is equal to 103.37 plus J 37.62 plus the last term is 113.25 minus J 19.97, and this is equal to 105.54 plus J 5.88. In the polar form, this is equal to 105.7 angle 3.19 degrees. This is the positive sequence current in the A phase. Now we need to find out the positive sequence current in the other two phases also. This is the positive sequence phasor diagram. IA1, IB1, this is IC1. The vectors are rotating in the anti-clockwise direction. What is IB1? IB1 equals IA1 into 1 angle 240 degrees. This is 240 degrees. Or it is alpha square into IA1. This is equal to 1 angle 240 degrees into 105.7 angle 3.19 degrees. So this is equal to 105.7 angle 243.19, and IC1 is equal to, this is IC1, it leads the reference IA1 by 120 degrees, or IC1 equals alpha into IA1. This is 1 angle 120 degrees into 105.7 angle 3.19 degrees. This is equal to 105.7 angle 123.19 degrees. So these are the three positive sequence currents. The positive sequence currents in the three phases. Now let's find out the negative sequence currents. IA2 equals 1 by 3 into, it is IA plus alpha square IB plus alpha into IC. It is IA plus alpha square IB plus alpha into IC. And this is equal to 1 by 3 into 100 angle 0 plus alpha square is 1 angle 240 into IB equals 110 angle minus 100 plus alpha equals 1 angle 120 into IC equals 115 angle 110 degrees. This is equal to 1 by 3 into 100 angle 0 plus 110 angle 240 minus 100. So this is 140 plus 115 angle 120 plus 110. This is 230. This is equal to 1 by 3 into, let's convert these polar terms into rectangular terms, as we need to add the three quantities. This is 100 plus J0 plus the second term is minus 84.26 plus J 70.71. The third term is minus 73.92 minus J 88.1, and this is equal to minus 19.39 minus J 5.8. The final answer of this current should be written in the polar form. This is equal to 20.24 angle minus 163.35 degrees. This is our A phase negative sequence current. Now we need to find out the negative sequence current in the other two phases also. IB2 equals, this is IA2, this is IB2, this is IC2. IB2 equals alpha into IA2. IB2 leads IA2 by 120 degrees. It is alpha IA2. It is one angle 120 degrees into 20.24 angle minus 163.35 degrees. And this is equal to 20.24 angle minus 43.35 degrees. IC2 equals, IC2 leads IA2 by 240 degrees, or IC2 equals alpha square into IA2. This one angle 240 into 20.24 angle minus 163.35, and this is equal to 20.24 angle 76.61. So these are the three negative sequence currents. So now we have found out zero sequence currents, positive sequence currents and the negative sequence currents in the three phases. So when you convert an unbalanced set of currents, unbalanced set of phase currents into sequence currents, we will get non-zero quantities for zero sequence, positive sequence and a negative sequence. But if you convert a balanced three-phase current, a set of balanced three-phase currents into sequence currents, then you will get only positive sequence currents. The other two components, zero and the negative components, will be zero.